Hey, what's up, guys? So let's solve this famous Leetcode problem: 2 to 1 maximum square. Oh, so basically you get grids, and then you only count one, and you need to find the largest square containing only one. So 1, 1, 1, 1, right? This is 4, right? So you need to find the largest square, then returns area. So area is stupid, right? Area just the since it's square, so the area just the length square, right? So we just need to find the maximum length. Okay. And this problem can be solved by using simple DP. Okay, so let me just quickly solve it. So you can define a dpij to be the maximum length ends at ij. Okay, so probably this is not easy to see what it means. Basically, you can define let's say this is ij, this is ij coordinate. If this is 1, then the let's maybe do this. Let's see, this is the grid, and then this is ij, and if ij is 1, right, then the dpij means the maximum length. The maximum length that this is all 1. So basically, it's the answer. This is the 1. So these are all 1. Okay, and the least length L. Okay, so dpij is defined as L. Okay. Okay, so if all of these are 1, is the largest matrix that with the length L square matrix are all 1. This is defined to be dpij. Okay, then one can simply write the relationship with dpij with the results, or with the transition equation, right? For example, you can see this, right? So if this is the dpij, now this is dpi minus 1j. This is I, this is j. Right, so this should be dpi j minus 1, and this is dpi minus 1 j minus 1, right? So obviously that your dpij is basically a minimum, right? Because if these has some square, and this minimum dpi j minus 1, and the dpi minus 1 j, and the dpi minus 1 j minus 1, or not square, correct? And plus 1. This equation can hold if if ij itself is 1. Because if ij itself is 1, then I can do updates, right? So if nums of ij is 1, then I can do this. Otherwise I just initialize dpij to be what? To be 0, right? Right. That's it. Okay, so maybe this is hard to see, but let me just do this example. So let's do this simple example. Let's do this. Right. So for the initialization, I can initialize this. So for now, I can initialize. I can first compute this line and this line, right? So this line is 0, 0, 1, 0, 0, right? Because in this line, there's no way that I can in these straight lines or this straight line, the maximum square is at most 1, right? So this is 1, 1, 1. So for this guy 0, right? And for this guy, this is 1, right? So but updates minimum of 0, 1, and 1. So minimum 0, so this guy is 1. Right? For this guy is 0, right? Because 0. And for this guy is 0. Sorry, I need to, sorry. Yeah, for this one, this is 1, 0, right? This is 1, and this is 1, right? 1, 1, 0, but this guy is 0, right? So it's 1, right? And now for this guy 0, this guy is 1. And now for this guy, you see for this guy that 1, 1, 1, the minimum is 1, right? So this guy can be updated to 2. Okay, and then now you understand the trick, right? So this is 1, this guy is 2, right? So the answer is 2 squared. Okay, so that's it. So your mn define and the dp 0 to be define it, and the result is 0, and it goes through this line, right? You go through this line, and this matrix I0 is 1. That means you can initialize it to be 1, and the results can be updated to be 1, right? Because you add, if all of the 0, then you don't have, your answer will be 0. And then we go through for this line, and if matrix 0j is 1, then dp0j is 1, right? And then you go through each line and you update the equation, right? If it's 1, you can use this equation, and the results dp to be this. So these results keep maximum. Finally, return the result square. Okay, so this is a transition equation that I just say. And if dpij is 0, then you don't have to do anything, right? But because when I initialize everything, I initialize everything to be 0. Okay, so that's it. See you guys next videos.